Hello, everyone. Hope you're enjoying the SIOS Cloud Availability Symposium 2022 so far. In this session, I'm going to talk to you about business continuity considerations for hybrid and cloud-based SQL Server deployments. That's a lot of words to basically say. I'm going to talk to you about how to achieve high availability in the cloud or whether you're stretching on-premises to the cloud. Just a quick little bit about me. My name is Alan Hurt. I've been working with SQL Server since it was a Sybase product. I'm currently a dual Microsoft MVP, and I'm also a VMware vExpert. I work with customers every day at SQL HA to help them transform their environments and get them to places like the cloud or create hybrid environments. So what I'm going to be talking to you about today is something I do all the time in customer environments. So the quick agenda for the next roughly 45 minutes to an hour is I'm going to talk about some basics. Then we're going to talk about what options you have in SQL Server. And finally, I'm going to give you some tips and tricks that aren't necessarily just availability related. Before we get started, I need to give you some basic definitions which are going to set the foundation for the rest of this talk. First up, let's talk about what high availability is. To me, high availability is you can survive some kind of failure that's much more local. So same data center, or if you're up in the cloud, say same region, right? Like a data center failure in a region shouldn't give you a lot of agita because there's redundancies you have in the cloud. But, at the more local, say on-premises level, we're talking about like server failure and you can quickly fail over somewhere else. But this is a more contained kind of a thing. Disaster recovery, however, is if, let's say, your primary data center on premises is a smoking hole in the ground, or your primary region in Azure is not functioning. At that point, you need to go somewhere else. That, to me, is disaster recovery. However, all this, at the end of the day, really is about business continuity because we're not doing a technology exercise. We employ these various features and technologies because we want to make sure that the business continues to run in the event something happens. So that's why I couch this all in terms of business continuity. Sure, features are great, but if you're leading with that and that's the reason you're doing this, you're probably not thinking about the right things. And oftentimes, to that last bullet point, you can't just add availability later. You have to generally bake it into the architecture from the moment you deploy it. Sometimes you can bolt it on, but the reality is more often than not, that's not true. A few other quick things that I want to address here. First of all, as data professionals, or as somebody who might be responsible for SQL Server databases, there are two key things that you should really think about as you're going to deploy an architecture or even existing ones. And these things need to be iterated on over time. First off is recovery time objective, or RTO. That's how long you have to get back up and running. That might be different from a more local failure, i.e. high availability, versus disaster recovery, where you got to bring up something in another data center and there's a whole lot more that you might need to get online. Because there's, say, Active Directory that might not be working, the app server may need to be up before a SQL server. Whatever that is, it's a more complex operation, So you can't treat the RTO for something that's a smaller event necessarily the same as something that's a larger event. Similarly, there's the concept of a recovery point objective, or RPO. This is the point in time where you're trying to get the data back to in the event of a problem. Most companies will tell you they want no data loss, which is a 0 RPO. That might be possible, it might not be possible. Especially in a disaster recovery scenario, you need to really have realistic numbers as to what that can be, because there are a lot of factors that go into that. Now, we won't have time in this session to explore all the nuances of that, but just understand that these things are not just a number you pick out of a hat. These are things that you need to really know your environment and know your applications and know the business, along with things like regulatory issues, compliance, you name it, that all factors in. Finally, one thing I want to mention here, and let me show you, is that any service level agreement, of which the cloud is one of them, of which something like an RTO is one of them, it's just a very specific form of SLA. This is Azure's service level agreement for virtual machines, and the reason I'm showing you this will become apparent in a few slides. But notice here, and I'm going to zoom in, it's legal service level agreements. So it doesn't matter what you come up with to a degree, because you're bound by the platforms you use. So you can't have necessarily a higher service level per se than what your platforms are going to guarantee for you. So I'm just pointing this out because it's nice to say a lot of things, but at the end of the day, your measurements to a degree are based on things like this. So just keep that in mind again as we start going through this talk and we start looking at options. There are really two types of cloud deployments, and we're going to focus on one and really not the other. There's infrastructure as a service, or IaaS, which is just a virtual machine in the cloud and everything that comes along with that for the most part. So it's an operating system where you will have SQL Server running inside of it. That operating system these days could be Windows Server or Linux. I'm not sort of lumping containers into IaaS really, because that's not quite a server as I see it, in the traditional sense that we've managed virtual machines today. There's also platform as a service, or PaaS. That's things like Amazon RDS, Azure SQL Database, Azure SQL Managed Instance. Those are not a virtual machine that you have access to running an OS with a full installation of SQL Server. Even if that's what's happening behind the scenes in some of the cases, you don't have access to that. You have access to what they show you. You might get just a database. You might get what appears to be SQL Server, but not everything behind it. So your level of control there is what the platform gives you for availability. Some of it might just be a checkbox. Some of it might be done for you already. So we're going to focus on that first bit, which is IaaS, because that's really the crux of the problem for a lot of folks today. Now, the other thing you need to think about here is that something like PaaS is what many people call cloud native. Cloud native is basically, it's a pure cloud-only feature, technology, whatever you want to call it. Something like IaaS, while it's a virtual machine, you're still managing that operating system. It's traditionally what we know, right? So keep that in mind as you think about your migrations and transformations and how you want to ultimately approach going to a cloud provider. There's sort of an in-between state, okay? And that's called hybrid. So what exactly is hybrid? Obviously, we know what on-premises is. That's physical or virtual servers that you manage, deploy everything in some kind of earth data center, whether you own the data center, the racks, your co-location, whatever that is. I say public cloud because really you log in with a browser, and even if you have a private connection, one of these cloud providers are all out there, right? Because cloud has been overused, because there's private cloud, there's a whole bunch of other concepts. That's why I'm calling Azure, AWS, Google, Oracle's clouds what I call public cloud. Hybrid is really the intersection of those two. And that is what I see a lot of customers doing today, where they have one foot and some footprint on premises in their earth data center or data centers, and then they stretch those architectures up to the cloud or rely on resources in the cloud. And that's that intersection right there in the middle. Now remember, as a general rule of thumb, you don't need to be all in the cloud or all on premises. You could transition and have this hybrid state, maybe with the eye towards being all cloud. But right now, for a lot of folks, hybrid is really what they're going to be doing for at least the near term. Some of you might be doing cloud native, and we're going to talk about what that looks like from a SQL Server perspective as well coming up here. For purposes of this discussion and in general, when we're talking things like hybrid, it doesn't matter if on-premises you still have physical servers, if you have VMs running on a hypervisor host, they're essentially the same from an architecture standpoint when you want to extend up to a cloud provider. Now, the thing you need to keep in mind as you're doing all this, and this is going to be something that in your environments you really need to think about, is that when you stretch up to that cloud provider, Azure, AWS, GCP, you might need core bits of infrastructure. Like, for example, just having Active Directory on premises generally won't work if you've got stuff up in the cloud too in IaaS. You probably want to have a domain controller sitting up in your cloud provider as well, or potentially multiple domain controllers. Things like that need to be all sorted out. We're focusing on SQL Server here, but remember, SQL Server is a part of a bigger puzzle, right? And one thing we're going to discuss is networking. And networking is going to be the linchpin of a lot of this stuff. And you need to basically securely have a connection to get up there. You don't want to be using a bunch of public stuff. And again, we're going to talk about things like that. Now let's talk about SQL Server and what options are available to you if you're using IaaS. So first of all, if you're not going to use the cloud to host SQL Server, potentially you could use it to store your backups. I still see customer environments where they are storing copies of their backup copies, I should say, of their databases on premises somewhere. I'm not saying there's anything wrong with that, but the cloud is a very easy way to get things off of your on-premises servers or data domains or however you're storing your backups to someplace that's not on site. Obviously, you need to think about how you may get those back down, the time that would take, the security around that. I'm not saying there aren't challenges you need to solve for your environment. But what I'm saying is that it's a low-hanging fruit piece if you're not doing anything in the cloud right now, or even if you are, another way to leverage it. Now, you can either copy backup files you generate on premises, however you prefer to do that, to a cloud provider, or potentially generate your native SQL Server backup to the cloud. For example, in SQL Server 2022, they're adding in the feature that you can back up now to an S3 bucket. That wasn't in SQL Server previously. Obviously, prior to that, you could back up to Azure. If you present an SMB share up in one of your public cloud providers and it's accessible from on-premises, you could do that too. There's a whole lot of stuff you can do now to make this easier, and it's not a lot of rigmarole where you need to get other people involved. One more thing I want to mention here that you could also do, and it's that second bullet point at the top, is after your things are up there, maybe you don't have the capacity on premises to test your restores. Well, what would happen if you spun up an IaaS VM and tested your restores? It might be just, again, something to consider is another use of a cloud provider. Now let's get into the availability features baked into SQL Server and have been for a while. First up is a failover cluster instance, or FCI. The full name for this feature is an always-on failover cluster instance. Always-on is the umbrella term which covers a few features, including availability groups, which we'll talk about next. But an FCI has been in SQL Server going back to SQL Server 6.5. This provides instance-level protection. And what that means is the entire instance, if there's a problem, will fail over from one host to another. And in this case, we're talking, in the cloud, it would be a VM. So what does that look like? So if you look at the animatic that I'll show you here in a second, this FCI, and I'm keeping it simple, I only have one running here, is part of a 2-node Windows Server failover cluster. Potentially this could be Pacemaker on Linux as well. And that solid line there going down to the storage means that that is the node that owns the storage. The dotted line means that potentially in a failover, the storage can be seen by that node, but it's currently not at this time. A problem happens in the VM, whatever, and that FCI automatically fails over to the other node. That's how FCIs work. That's what most people think of when they think of, you say the word cluster in SQL Server. That's traditionally what we've had. FCRs are great, but you need to think about when they were architected. When they were introduced in the late 90s, early 2000, in SQL 6.5, and further enhanced in SQL Server 2000 and later, we were using it in a physical world. And clusters, inherently things like Windows Server failover clusters and Pacemaker, were designed with physical hardware in mind. So things like a network card failure, processor failure, motherboard failure. Well, you can still use this stuff in virtualization and up in the cloud. That's all still valid, but understand you're probably not going to have a virtual machine vCPU just die on you. So the conditions that cause a failover might be a little bit different in a virtual world. SQL Server has accounted for this for a bit in the way it does health detection in the modern versions, but understand that the clustering mechanisms that sit underneath all these features were originally designed in an era that were based on physical servers. Now, the challenge here is that shared storage at the bottom that I talked about, where one node can own it at a time for that instance. Presenting shared storage, whether on-premises virtual, which I'm not focusing on, or up in a cloud provider, can be challenging. Some of the cloud providers like Azure do have a native way of doing it. In Azure, it's Azure Shared Disk. However, that may only be available in certain regions and require you to do certain things. So you need to really think about, isn't FCI the right architecture for you in this modern day and age? I've implemented it for customers because it's what we needed to do. It's still valid, but you need to think through your use case. Don't just take what you used to do on premises and say, well, we did FCIs in the past, we should just do them in the cloud. Not necessarily a thing. For storage, you could also use SIOS Data Keeper, which I've used with customers. It works great. It works in all of the cloud providers. It even works on premises. And it is basically one of the only ways to stretch your storage from on premises to the cloud. So you could, it could potentially create your hybrid scenario. Whereas stretching, say, a traditional SAN-based storage, which you might have on premises, and extending an FCI up to the cloud may not be possible, right? So cloud native, you would have to look at what the cloud provider does or do something in guests, such as SMB shares or present storage in another way. Whereas if you're looking for hybrid, something like SIOS Data Keeper could be potentially a great solution for you. Again, it all depends if this is what you want or need to do. Let's look at always-on availability groups. Now, AGs have been in SQL Server since 2012, so we're coming up on 10 years plus at this point if you're going to go back to the pre-release versions. They introduced AGs into Standard Edition in SQL Server 2016. That's a good thing, but you're limited to 2 replicas as part of the availability group, which potentially could be a little limiting, so you need to think about that. There are other restrictions that come in with AGs in Standard Edition. Just so you know, SQL Server marketing called AGs in Standard Edition basic availability groups, but we don't use that nomenclature, for example, basic FCIs or, basic log shipping, right? So just understand whether somebody says basic availability group or availability groups in standard, it's the same thing. So here we have just an example of what this looks like. If you look at that picture, you have on-premises or potentially, say, a region in the cloud. And then on the right-hand side, you've got another region, so you would be spanning regions here. Now you could put the two in the same region. That would give you high availability. But I'm showing you here more from like an overall business continuity disaster recovery standpoint. So you're looking to stretch this potentially across two regions or on-premises to the cloud and using cloud as DR. And that's pretty straightforward, right? It makes sense. This is what you get in standard, but what you need to think about from a Windows Server failover cluster perspective, or if you're using Pacemaker, is what you're doing essentially for in case of a Windows Server failover cluster, Witness, and in the case of Pacemaker, Stoneth, which is part of the quorum mechanism that helps keep your cluster up and running. So your data movement is going to look like this. It's going to be synchronized from P, which is your primary replica, to your secondary replica. And for example, are you going to use something like a file share witness where your primary replica is? That's valid, but could potentially cause other issues. I'm not sure we have time to get into all the depths of quorum. I have other talks on that. I think somewhere on the internet, or you could ping me and ask a question. But witness is an issue. Are you going to maybe put it here? Or are you going to use something like Azure Cloud Witness, right? Cloud Witness is introduced in Windows Server 2016, and while it's Azure only, is a great option. Now, obviously, if you're using AWS or using GCP, it may not be an attractive option, but Cloud Witness is just deals with your storage account in Azure, so it might still be possible. But if you're a single cloud shop and you're not using Azure, obviously you got to figure the other stuff out. Now, how do you get better availability if you're looking to stretch? This is where FCIs may come in. So you would have local availability in each region or on premises, or wherever it is, and then you create an availability group between the two FCIs. This is obviously a more complex scenario, but this would give you better local availability and local failover in the event something happens. Am I saying you should absolutely do this? No, but I'm just showing you potential options of how this may look. Now, Enterprise Edition, we can go beyond two replicas. So you have a single primary replica feeding multiple secondary replicas. Now here, notice I only have one in the cloud provider, right? Or one in our DR, if you will. I could add another if I want to make sure that in the event I have a problem, that I could have local failover. Obviously, there are potentially licensing issues depending on how you're licensing SQL Server. Add a scope for this talk. This is obviously inherently more difficult in the way of where you put the witness. Because again, if you're spending, especially on premises and whatnot, that could be an issue, or different cloud providers. If you're not able to use Cloud Witness, again, all solvable things, but you got to think these things through. There are other things you might want to do to the cluster configuration, which we'll talk about here in a couple moments. But understand that this is tried and true. This and what I showed, this is basically the same as what I showed here, just with more replicas, okay? Now, there is something else in SQL Server, and that is called a distributed availability group. It is something that was introduced in SQL Server 2016, Enterprise Edition only. So if you have Standard Edition, this isn't applicable for you. But what this is what a lot of us have come to call it as, which is an AG of AGs. Now, the distributed availability group concept is simple. You have, notice here in this picture on the left, I've got an availability group running in, say, my on-premises data center or up in a cloud region, and I want to extend that to another region, or if I'm on-premises, to the cloud in a hybrid scenario. They each have their own Windows Server cluster mechanism. They each, like in this case, have their own witness resource. So you're keeping all that local. The complexity of where you put that stuff is much better. Now, while you do have two different primaries, because I have two different availability groups known as P1 and P2, in the case of a distributed availability group, there's one read-write copy of the database, and that's at what is known as the global primary, or what P1 is. And P1 will send the data to S1 as well as P2. And P2, which is the forwarder, synchronizes S2. Now, this construct is purely SQL Server only. It will never show up. For example, if you're running a Windows Server failover cluster, you won't see resources associated with it. But the good thing here is that because it's SQL Server, it's all managed in SQL Server. And what you're doing here is you're trading off some complexity. So the complexity moves essentially into SQL Server versus at using this, the complexity to a degree is more at the Windows Server failover cluster layer. So one isn't necessarily better than the other. They're just different shades of the same thing, in a way. Now, I've had customers use distributed availability groups to span parts of the country. It's a good way to do test failovers, I've found. Yeah, there's so many good things about distributed availability groups, but you have to be really comfortable with things like T-SQL and distributed management views. So if you're not, they're not a good candidate to implement, but they are good overall. So I do recommend them, but you need to know your scenarios. I've talked about some of these in terms of our availability architecture. Obviously, witness location does matter. In terms of a Windows Server failover cluster, there's a concept of, the servers or the nodes of the cluster belonging to a site and then setting a preferred site so that the resources will try and run in one place, and maybe updating voting preferences. All that stuff might need to be handled here. Again, sort of out of scope for the time we have here, but just understand that there are things you may need to tweak in your cluster to make it better to span these types of distances. Now, one thing which you need to understand, or at least somebody in your org needs to understand, is that when you're spanning on-premises and the cloud, you're going to have multiple subnets, or you're going from zone to zone or region to region. You need to be able to get things to talk. Now, if we're going from on-premises to the cloud, securely you could do something like a site-to-site VPN, but you're still not going to necessarily be able to extend your subnets that are on-premises in your cloud provider. So you're going to need a way to translate and route those things there. I recommend using some of the more native direct stuff, like Direct Connect, that gives you a direct pipe up to, say, your cloud provider. But each one has its own, and they can be expensive, but you may get the bandwidth you need. So you got to deal with subnets, you got to deal with how you're getting from here to there. VPNs are secure, but then you're going over the public internet, and you're relegated to whatever your internet service provider can provide you. There's a whole lot of stuff. When you're deploying a Windows Server failover cluster in Azure, to make sure you can connect to your availability group using the listener or the name of your failover cluster instance, you either need to create a load balancer or use a distributed network name. You can look those up, but just understand Azure here is a little bit different than the other two. Don't recommend using any public IP addresses for things like a load balancer or accessing SQL Server. You're just asking for trouble. This is why I said you need those private direct connection links, be it a VPN or something else. And other things you might need to adjust in the cluster too, such as the networking threshold, so that you're more tolerant of your distance in networking. You would sometimes have to do this on premises, but I've seen especially cases up in the clouds where, because of the way things are architected on the back end, that might need to be done as well. Now, availability group specific stuff. How are you going to initialize your replicas in the cloud? It's from a backup, but how are you getting your backup to the cloud? Your network bandwidth becomes huge here. So you need to really understand what that is. And plan for that. I've had customers where they've had multi-terabytes of data, and just to get the copy up there has taken 24 hours. And if you've got terabytes or petabytes of data, understand that could take some time. Then you have to do the restore. So just think about that. As a general rule, AGs should be run asynchronously between data centers or on-premises to the cloud or region to region. I mean, it's DR, right? So now you might be able to run sync, but as a general rule of thumb, I tend to want to do that. Now, distributed availability groups as a normal course is designed to run asynchronously. If you're going to do a controlled failover, you might set synchronous, make sure everything is synchronized. But for the most part, you're going to be running that stuff async. Now, the interesting thing on that last bullet point is this. Do you need to, for example, go back on premises? So I've had customers where their primary systems are in Azure, but for a while or for redundancy purposes, they do have some stuff going back on premises. Now, from a practical standpoint, everything I've talked about to date about sites and potentially modifying stuff in the Windows Server failover cluster, all that kind of stuff is valid because it doesn't matter whether the cloud is your primary or on-premises is your primary. That kind of stuff is the same. But what you need to understand is that there is a cost of taking data and sending it out of the cloud. That's called egress. And if you have very busy systems, it might potentially be something that drives up your consumption costs. So you need to really think about, for example, are you going to go back on premises? How are you pulling data back? All this stuff starts to matter, whereas on premises, if you're going between one data center or two data centers or more, nobody's really thinking about the cost other than the network pipe that you have to pay for because you're not paying for ingress or egress. Ingress is taking things into the cloud. Egress is taking things out. So again, keep that in mind in the back of your mind because cost is going to become a factor in all this. And that'll become more apparent as I get into some of the tips, tricks, and best practices. Another tried and true option for availability is our good friend log shipping. Log shipping is one of the oldest SQL Server availability features. It's just based on backup, copy, and restore. And it was officially put in the product a long time ago in SQL Server 7, but it existed before that in other ways. And what is log shipping? Simply put, you take a full copy, you restore it to a secondary or warm standby, you restore it with no recovery or with standby, and then you have T-log backups that are generated automatically, copied, and applied, and that process happens ad infinitum. So you're only as good as the last T-log you have access to. This will account for things like network latencies, all that other kind of stuff. Log shipping is an awful reporting solution. If you need that, I would really recommend looking at something else, like, for example, an enterprise edition of SQL Server with availability groups. You can have readable secondaries, but that's not really what we're talking about here, because that's not an availability feature. That's a nice to have as part of all this. So here, this just works. I mean, you could do this today, going to the cloud without knowing anything about clusters or anything else. So don't discount log shipping as a potential method for creating business continuity in the cloud. You know, this also potentially is a way of extending an FCI. If you have, say, let's go back to that availability groups picture for a second in standard edition. Theorize, for example, that these two servers are in the same data center or same region in the cloud, right? Well, you could use log shipping to get that to the other region, right? So that's yet another option besides something like this in standard edition. So again, just showing you what's possible I'm not telling you what you have to do because you need to figure those things out for yourself based on your requirements and a whole bunch of other factors to get you that SQL Server level resiliency. If you're using a single cloud provider or you're deploying cloud native, your VMs themselves have redundancy features built in, both at the VM layer and at the storage layers. So let's have a look here. Now, here I've got, for example, I'm going to create something in Azure. And notice here, I have availability options. And let me zoom in here real quick. I have availability zones. So basically, when they say physically separate your resources within an Azure region, they're basically talking different data centers. Remember that introduces slight latency, but that's not necessarily a bad thing here. You probably won't notice it, but it physically separates out where this VM would be running versus, say, another one in this configuration. So if you're running, let's say, an availability group, and you wanted to put two replicas in the same region, an availability zone, if the region supported it, would be a great thing because those IaaS VMs would be running in different data centers. You can also do an availability set, which is based on fault domains, and the fault domain, actually, let me, I don't have one, but let me just, so here, I'll create one, and you'll see here it says create availability set. And I'll do like SIOS AS. And basically, you're telling, and you can look at the descriptions, right? But basically, you're trying to tell Azure in this case, and availability sets is something specific to Azure, where, hey, please don't, if you're hosting my VM, please don't put it in the same power and chassis as the other VM or VMs that'll be part of this availability set, okay? And that's just one of those things. Now, so let's do this. Great. Now, you also have things with disks. So, for example, if I create, this is just a basic virtual machine. This is not using the SQL Server template, right? If I wanted to create a disk, okay, I'm going to change this, and I could change the size, whatever. But I could say, for example, I want it to be locally redundant, zone redundant if I'm in a zone. So you have ways of making sure that things are protected from a configuration standpoint. And all the clouds have similar concepts. Let me be clear. I'm just showing you in Azure, but AWS has this too, GCP. So you need to look up your cloud provider of choice and see what they do at this level, because this becomes part of your architecture of protecting and adding resiliency and business continuity to your IaaS VMs in the cloud, okay? Before I move on to just general tips, tricks, best practices, you need to think about a couple of things. And really is, I showed you a bunch of stuff about SQL Server and what's built in and you're using IaaS VMs, but are there other things? If you're using VMware for your virtualization, well, you know, you can use the VMware Cloud Solutions. You can use Site Recovery Manager, which is a feature built in. You can vMotion. You can use Azure Site Recovery in Azure, AWS Cloud Endure for AWS. So that's giving you VM level protection. That isn't protecting things inside the VM from, say, a transaction level where you care about things like RPO, for example. This is more VM level protection, but for certain scenarios, this may be perfectly fine. So everything I've talked about before was very Windows OS, SQL Server specific, whereas this is more generic, and something like Azure Site Recovery works with other things too, like your web servers or file servers or whatever. Everything isn't all or nothing. You may use different approaches for different solutions based on their requirements, and which is always how you should approach things. You should never do a one-size-fits-all if at all possible. Finally, let's talk about some tips and tricks as they relate to SQL Server and going to cloud deployments. First of all, before you even can get into availability and all the other stuff that I talked about before, if you're looking to use a cloud, be it just for DR, cloud native, whatever you're looking to do you know your workload today? What it looks like, its performance, its characteristics? Have you sized it properly on premises, or are you tight on premises with your VMs today for using virtualization? Are you maxed out? Do you know what your growth patterns have been? You need to know all this stuff, and there's a really good reason for this. Because if you don't have current baselines and benchmarks, and I'm not talking take a day's worth of data and get that. You need to do it over time and see what it looks like on busy days, on slow days, sort of get an average, but know that, for example, you may need to scale up. You have, let's say if you're an online retailer, when you get hit like the last quarter of the year and you have Black Friday sales, your usage may be higher than the rest of the year. So you have to account for all those kinds of things. Because if you don't know those numbers and the kind of throughput you need, CPUs, memory, you don't necessarily have the flexibility in the cloud. And I'm going to talk to you about that here in a moment. I mentioned this before, but I want to be very clear. Just taking what you're doing on premises today and redoing it in a cloud provider. So if you're using FCIs today, or even if you're using availability groups, they're supported. They're great features in SQL Server. But just doing what you do today isn't something you should do, per se. Maybe you do need to do that, or maybe it is the best idea, but should you maybe be re-architecting? Is everything that's a virtual machine or a physical server today, could that be PaaS? For the things that need to be IaaS and VMs in the cloud, can we optimize them better than we were running them today? All that stuff matters because that will give you better reliability. And the key there, more than just not doing lift and shift, is if you're having current problems and challenges, you don't want to take all that baggage with you when you go to the cloud, because then you're just perpetuating everything you've done in the past. And you might want to look at this as a fresh start to clean up some things that maybe not have been as good as you hoped, right? Okay. Now, a big part of performance, but also availability, and I'll show you here in a second what that means, is that choosing your virtual machine size for IaaS deployments in the cloud matters. It's not like on premises where if you want to give it, let's take licensing out of the picture here. Let me be very clear here. What you don't have is the ability to say, I want to give this 10 vCPUs, right? If that's all you need. And you may not have the ability to say, I want to give it vCPUs, like 2 vCPUs and 8 vCores, each vCPU. You may not have any of that. You basically have fixed sizes in the cloud providers that you get to choose from. So you'll see what I mean here in a minute, but there's going to become some trade-offs. Like if you need higher IOPS, you may need to pick a bigger VM. Because the thing is, the bigger the VM, obviously the bigger the cost. So if you greatly oversize your VM for more than you need, you're going to pay a lot. If you undersize, your performance is going to be terrible. So you need to find that Goldilocks size that it's just right and that gives you some growth. The other thing about this is that you're gated on performance. Those VM sizes have caps and limitations. That's what I want to show you here in a minute. Let's look at this. This is EC2. Just to show you, I'm not showing you Azure stuff. We're talking about Azure. We could, let's say, look at a storage optimized VM. So I just picked one here, an i4i. You'll have to figure out what the best one is for you. We're not getting, that's again out of scope for what we're talking about here. But they tell you what the limitations are, and they tell you what kind of processor. Now, Glenn Allen Berry has great guidance on all this stuff. He's written a book. He's a really great guy when it comes to hardware. So, you need to look at, does the processor make sense for you, right? And here they're telling you what it is. Azure does the same thing. They say we're using Intel processors or AMD, and the type it is, so you can make choices of how to run your workload. But here, for example, look at this. Your network bandwidth is, 10 gigabit per second. But you notice as you go up to, for example, an i4, i16X large, your EBS or your elastic block storage, or the bandwidth between you and your storage, goes up. So if you're pushing a lot of throughput, you may need to use that even if your databases are not super large, right? It's all based on knowing your environment. And I'm giving you the quick 2-second version of this. Azure has their own, right? And notice here, again, you don't have a choice on sizes, right? So if you need this, but from a CPU, you only need 16, well, guess what? You're paying for this. And obviously that affects your licensing costs. It affects your cost of the VM. There's a whole lot of things here. So making sure that your VMs are sized appropriately matters. And again, optimizing your workload so they run as efficient as possible, I think now you can see why that needs to be. Understand that since we're talking about business continuity, oftentimes one of the best parts of the cloud is that you can resize this stuff, you can make it bigger, you can make it smaller, but that often incurs downtime. So you want to get this right as much as possible out of the gate. Build versus buy simply means, do you take one of their images with SQL Server and does it meet your standards? Or do you take a base Windows image, or do you upload an image to your cloud provider and use your own? It's not going to affect licensing necessarily in that way, because obviously the vCPUs and the memory is going to be what it's going to be, and that kind of. But you need to really think about, how you want to deploy up in the cloud. Just like on-premises virtualization, you can reserve capacity, meaning guarantee yourself, memory and CPU and stuff like that, instead of being, just a VM running on a host and then maybe somebody could swipe some stuff from you. And the last thing I'm going to say here is that last bullet point, which is I often see a lot of folks underpower their DR servers to save money. I get it. Totally do. However, understand that that has an impact on how far behind it could be, because as you saw, your network performance is gated, your storage performance is gated. So if you make that smaller, it'll be synchronizing with, say, your primary replica in an availability group, but that secondary replica might be farther behind because it doesn't have the resources to be quicker. So again, choosing the right VM size based on a lot of factors, including your RTO and RPO, is important. Finally, let's talk about storage itself. Don't ever use the system drives for SQL Server data log or backups. It's standard best practice, but again, people do silly things sometimes. That means all the other storage that you have attached to the VM needs to be done appropriately. All the clouds, to a degree, depending on the VM you pick, some of them may have it, some of them may not. But a lot of the local storage, and that's locally attached disks, not the ones that you carve out that, say, are network disks, which is what most of it is, like EBS, for example, or creating an Azure, like a P30. Those are disks that essentially go over networking to get to your storage. And that's why network bandwidth also matters as well. But there is the concept of having locally attached disks. Some clouds have that locally attached disk where the block storage is permanent, and other ones where it's temporary. You need to understand the difference, because if it's temporary, the second you reboot that server, everything is gone. That's why you don't put your databases, your user databases, and important stuff there. Now, ephemeral disk, potentially, which is the name for a temporary disk like that, could be used potentially for something like TempDB, because oftentimes those locally attached disks that are presented up to the VMs have better performance in many cases than sometimes, and is a better option for things like TempDB, but it may not be as well, because the size VM will gate how big that ephemeral disk is. And if it's not big enough for your TempDB usage, you still have to put it on something like one of the premium disk in Azure or an EBS store or whatever, right? I already talked about the striping, but basically that's done inside your guest. So you would set up something like storage spaces, not store. I don't recommend storage spaces direct for SQL Server right now. In the cloud providers, just trust me on that one. It's fine, but it's better for other scenarios. SQL Server can be a little wonky. You have to ask yourself, like for example in Azure, do I get like a bigger monolithic ultra disk? Is the cost to price benefit ratio good or bad? Now, I wholeheartedly recommend that you test your performance to make sure A, you're getting what you expect, and B, that you've sized everything properly before you go into production. And that means using a workload or some other thing to simulate that. So understand that if you don't do that and you run into some issues, maybe you could have caught it before. Maybe you couldn't have, but oftentimes you can at least sort of figure some of that out. To sum things up, I talked about a lot of features and technology and tips and tricks, but business continuity is just that. We're trying to keep the business up and running. Everything we do from a technology and feature standpoint supports that. So lead with your requirements from the business side and apply them to the technical. Don't just say we're doing availability groups and then try and do square peg round hole. Sometimes that's not, or I should say not sometimes. I'd say 9.9 times out of 10, that's not the best approach to take. Always go in with solid requirements. Don't just say, again, I'm going to do an availability group, but not know your RTO and RPO. Because how do you know if the solution is going to meet that need? Technically, it'll work, but is it going to do what you want it to do? Is the business going to be happy? If you're running an operating system with SQL Server, it's just an operating system with SQL Server. So whether you're doing things up in the cloud or on premises, they're more similar, but yet there are lots of different things, especially when it comes to like the infrastructure bit, that are different in a cloud. So understand what those are. I talked to you a bit about some architectures may be more complex than others, and you may be trading certain complexities. My motto when I work with customers and all that other stuff is to try and keep it as simple as possible, because you want solutions that are not only perform well, are available and reliable, but also give you manageability as well. So don't make things so complex that you can't manage it. That's not a good look. Finally, as you saw by the last couple slides, knowing your workload, knowing your baselines, picking your VM size affects availability, right? It's not just performance. It affects configuration, obviously. But that kind of stuff, when you go into the cloud, a lot of things that we sort of took for granted because we had server capacity and didn't have to really think about things, now have an actual cost and potentially downtime associated with them if we get it wrong. Think about that as you're going forward. I hope you found this useful, and if you have any questions, I will put up my slide, which has my contact information. You can reach me on Twitter at SQLHA, or you can email me if you have questions. And thanks for attending this session and watching it. Hope you have a great rest of your day.